Lesson 4 is a review of the time value of money concept and calculations. Time value of money is not directly related to any of your cases, but the application of the concept will be used in your future case analysis and also the later chapters. If we look at this valuation graph, we understand value of a company depends on how much free cash flows the company can generate in the future. But these free cash flows are to be generated in the future, so to get the present value, we need a so-called discounting process. We are using the cost of capital, the WACC, as a discount rate to calculate the discounted value, or say the present value of each cash flow, each free cash flow, and we sum them up to get the total present value of all the future free cash flows the company is expected to generate in the future. So in this lesson, we are looking at the discounting process. We are trying to understand the discounting process and understand how to calculate the total present values. Before we introduce any calculation, let's take a look at the timeline. Setting up the timeline actually can help us to understand the cash flows involved in any time value or money problems. So I would highly recommend you to set up a timeline in all the time value or money analysis you're going to perform. So a timeline is actually just a straight line that connect the time with the amount of cash flows. For example, year 1 we have cash flow 1, year 2 we have cash flow 2. And if we want to record $100 due at the end of year 2, so that's $100 at the end of year 2 in this timeline. In this example, we have an investment of $50, and that's a cash outflow, so we use a negative sign for cash outflow or any investment. And if we receive $100 at the end of the first year, we put 100 under year 1. And if we receive $75 at the end of year 2, we put 75 under year 2. Now here we're looking at this timeline. We understand we are having $100 now at time 0. So time 0 generally is now, present. And if we have this $100 now and we try to invest it based on a 10% interest rate or rate of return, then we want to know how much money we would have by the end of year 3. So future value, how much is the future value at the end of year 3? This is the process of finding future values, and we call this process compounding. After 1 year, we understand we will have $100 generating 10% interest rate, so that's $10, and 100 plus 10, that's 110, principal plus interest. And if we put it in the formula, that is present value multiplied by 1 plus I being the interest rate. Now after 2 years, then this $100 will compound for twice, and that's why we are having present value multiplied by 1 plus I at the power of 2. So that would be $121 at the end of year 2. After 3 years, then we compound for 3 times, and then future value will be 133.1. So in general, future value in the future equals to present value, which you have now, multiplied by 1 plus I at the power of n. So I is the interest rate, n is the number of years that you have to compound. To get the results, we have 3 ways. We can just use a regular calculator, use the formula we just mentioned, and solve the equation, get the results. And we can also use a financial calculator, or we can use Excel spreadsheet to help us get the result pretty fast. I have a video uploaded in D2L that explains how to set up your financial calculator, BA2 Plus, or if you have Texas Instrument 83 or 85, 89, you can also use that kind of calculator, and I have videos to explain how to use your financial calculator to solve for the time value of money problems. So I highly recommend you to go check out those videos. It provides very detailed step-by-step explanation about how to solve for time value of money problems. So generally, financial calculator get the results by solving this equation, and as you see, future value, present value, interest rate, and number of years. These are 4 variables. If we know 3 of them, then we can solve for the 4th variable. So if you input 3 as n, 10 as interest rate, which means 10% interest rate, and a negative $100 as present value, and 0 as payment because there's no other payment involved, only $100 now, then in 3 years you compute for the future value, you will get 133.1. Again, check out the other video and see if you can follow and get the future value result. In Excel, we can get the future value result this way. I can type in equals to future value, then you see that Excel actually pops up some hints for you, so we'll just need to input the variables as hinted. So the rate is 10%, so I just put 10%. MPER means number of payments. Since we have 3 years, so we'll use 3 as MPER. And at this point, let's use 0 as PMT again because there is no other payment involved. And present value, we can use a negative 100, and that's it. We get the result of 133.1. You notice I'm using a negative 100 as a present value. You can take it as that if we invest $100, or say if we take $100 out of our pocket and invest it now, then in 3 years we will have $133.10 for us to withdraw. You can also use a positive 100 as the present value, then your result will be negative. So for example, 10%, 3, 0, 100, then you will get a negative result for the future value. But as you see, the amounts are the same. So here, you can think of it as you borrow $100 now, so you receive $100 now, and since you are bearing a 10% interest rate, then in 3 years you will have to pay $133.10 as your debt. Now, once we understand how to solve for the future value, we can also use the same formula to solve for the present value. So the question here is, what is the present value of $100 which is due in 3 years if we are looking at a 10% interest rate? So finding present value, this process is called discounting, and this is opposite of compounding. So again, compounding is to get the future value, while discounting is to find out the present value. And remember, this is the formula we use to calculate future value, right? And based on the same formula, we rewrite it, and we see the present value equals to future value divided by 1 plus I at the power of n. So if we have $100 in 3 years, discounted by 10%, and then we will have present value of $75.13. So this is after a big discount from $100. If we use the financial calculator, then what we need to input is 3 years as n, 10 as the interest rate, and then we input 100 as the future value. We still leave payment as 0, and we compute for the present value, we get $75.13. So again, if you put 75 and 13 today, then you can take out, or say you can receive $100 after 3 years if the interest rate, or say the rate of return, is 10%. If we want to use Excel, then we can use the PV functions in Excel directly. 10% interest rate, 3 years of discounting, no other payment. Future value 100, then compute present value, we get $75.13. 13 cents. We can also use the same formula to solve for the other variables in this formula. So for example, this is to calculate the time, the N. If you invest $1 now, how long would it take for your investment to double, or say to become $2 if the interest rate is 20% per year? We plug in the numbers into this formula, so $2 equals to $1 present value multiplied by 1 plus 20% at the power of n. So n is the unknown variable here that we try to solve. And mathematically, we can solve this formula this way, and we get the result, and will be 3.8 years. But using a financial calculator could make it a little bit easier and faster. So what we need to do is to put -1 as present value and +2 as future value. 20% interest rate, compute for the n, because n is the result we are looking for. So we compute for n. You notice that here, between present value and future value, one number is negative and then the other number is positive. It actually doesn't matter which one is positive, which one is negative. So as long as there is one number positive and the other one negative, then you can get n as the number of years that it would take for your investment to double. If you input both numbers as positive, then your calculator actually will give you an error message. Now, if we want to find the result here in Excel, well, now what we need to calculate is number of years, so NPER, and we need to tell the Excel that interest rate is 20%, no other payments. We have $1 investment, and we want $2 out of it. So it's about 3.8 years. If we want to find out the interest rates, same thing, same formula. We have this question. What kind of rate of return do you need to have to make your $1 investment today become $2 in 3 years? So comparing to the last question, well, we know 20% interest rate is what we have, and we needed to find out n. Here we don't know the interest rate. We know we want 3 years for the investment to double, so we want to know what kind of return can guarantee that. So plugging $2 as future value, $1 as present value, 3 years as n, so for the interest rate. And when we solve for the interest rate, it turns out to be 29.99%. And using the financial calculator, again, faster and easier. Present value as -1, future value as +1. Or you can put present value as +1, future value as -2. And you compute for the IY, and IY will turn out to be 25.99, almost 26%. With Excel, let's see, equals to rate. So rate is the function we use to solve for the interest rate. We have 3 years, no other payment, $1 investment becoming $2. So 25.99%, or say 26%. You can, of course, try to get more decimals. So 25.99, 21%. So as a summary, when we deal with just one cash flow, or say single cash flow, we have one formula with 4 variables, and we can use this function to solve for the missing variable if we know the value of the other 3 variables. We can use the financial calculator to help us. We can also use Excel to calculate any of those variables.